In this question, we are looking for the concentration of a percentage solution, in this case of BSA. So how are we going to address this question? Now, what we are looking for, as I said, is the concentration, and that would have, of course, a unit of mole per liter. Now, very big question, do we have mole somewhere? This unit, yes we have, but it's on the wrong side. So we have to write it as mole and 66,000 gram. Now the mole is okay, but we need to get rid of the grams. So do we have grams anywhere? Yes, we do, because we know that a 5% solution means 5 gram in 100 milliliter. So we can write this as 5 gram in 100 times 10 to the minus 3 liter. Now we see that the grams cancel out, and what we've got left is the unit mole per liter, and that is exactly what we want. So we finished with our writing down the different things, and we have 5 divided by 66,000, and I should write here mole, times 100 times 10 to the minus 3 liter, and if we put that in the calculator we get 7.58 times 10 to the minus 4 molar. This question asks us how much we have to weigh out, and that means we are looking for the unit of grams. And from the previous question we know that the molecular weight of BSA is 66,000 gram per mole. So do we have the unit that we are looking for? Do we have grams somewhere? Yes, we do. We have grams here. So we just simply write it so that the grams are on top, 66,000 gram per mole. Now the gram is good, but we want to get rid of the mole. So do we have mole somewhere? Yes, we have it here. We can write this as 2 times 10 to the minus 6 mole per liter. So the mole cancel out. We have the liter down here. We want to get rid of the liter. Do we have liters anywhere? Yes, we've got 10 milliliters. So we can write this as 10 times 10 to the minus 3 liters, and we say it cancels out. So what we have left is 66,000 times 2 times 10 to the minus 6 times 10 to the minus 3, and the unit is gram. And if we put that into the calculator, we get 0.00132 gram, or that would also be the same as 1.32 milligrams. Now this question asks us to use a stock solution, and we know how we can deal with the stock solution. We know that for stock solutions we can either use the equation C1V1 equals C2V2, or we can use my approach where I say, well, I imagine there is a patient going into pharmacy, and the doctor has written a prescription, and on this prescription it says I want 40 milliliter of a 1 millimolar solution, and the pharmacist says, sorry, we only have 100 millimolar solution, and that's already our calculation. So all we need to do is cancel that, and we have 40 milliliter divided by 100, and that gives us 0.4 milliliter of stock. And of course 39.6 milliliter of say water or buffer or whatever this compound should be dissolved in. This question is again very similar to the previous question. So again we have a stock solution, and what we can say is that the doctor wants 8 milliliter of a 0.5 millimolar solution, so that's our diluted solution. So we have 8 milliliter times 0.5 millimolar. That is what we want, and we have only 25 millimolar. Again, we can cancel that, so we have 8 milliliter times 0.5 divided by 25, and when we put that in the calculator we get 0.16 milliliter, and obviously we then need 7.84 milliliter of water or buffer or whatever, and this 0.16 milliliter, that was our stock solution. Again, this is a very similar question, so we can say the doctor wants 12.5 milliliter of a 0.5 millimolar solution, but we only have 50 millimolar. So the millimolar cancels out, and we have 12.5 milliliter times 0.5 divided by 50, and when we put that into the calculator we get 0.125 milliliter of stock, and obviously we get then the rest, we make that up with water. And here's another question. We don't have, in this case, we don't have molarity, but we have milligram per milliliter in our stock solution. So this is pretty much the same that we've done before, but we need to make sure that we are using the same units here. So milligram and microgram, we need to be a little bit careful here, but we still have the same equation. So we want to have 1 liter of 100 times 10 to the minus 6 gram per milliliter solution. That's our 100 microgram, and our stock solution we have 100 times 10 to the minus 3 gram per milliliter. Now we don't have to worry about the unit liter and milliliter here, because what we see is that these two units here, this gram per milliliter, cancel each other out. And actually the hundreds cancel each other out as well. So we have 1 liter times 10 to the minus 6 divided by 10 to the minus 3. And when we put that into our calculator, we get 1 times 10 to the minus 3 liter of stock, or this would also be the same as 1 milliliter of stock. And of course we would need 999 milliliter of water for that. Here again we have a very similar question to the previous one. We have milligram per milliliter, which is again a concentration, and here we've got microgram, so we need to be careful. So we do doctor times doctor, so the doctor wants 175 milliliter of the 100 times 10 to the minus 6 gram per milliliter, divided by, and that is what the pharmacist has, 62.5 times 10 to the minus 3 gram per milliliter. And I really only need to convert these milligrams and the micrograms. I don't have to worry about the milliliters or so, because they will cancel, these units cancel each other out. So what I have left is 175 times 100 times 10 to the minus 6 divided by 62.5 times 10 to the minus 3, and the unit would be milliliter. That's this guy here. So if I put that into my trusted calculator, I get 0.28 milliliter, and of course then the rest, which would be 174.72 milliliter of water. And this here was, of course, the stock solution.